Hello, my name is Logan Mackis, and today I will be presenting on behalf of Group 15 for EME 303. The group consists of myself, Corey Frias, Evan Antonacci, and Hector Rivera. The topic we selected for this project was, why does bullet accuracy improve with rifling? In the bottom of the screen, you can see that there are two different kinds of barrels. There's a rifled barrel and a smoothbore barrel. The rifled barrel is on the left with the lines indicating the rifling. The smoothbore barrel means there is none of these rifle lines inside of the barrel. Observations of this phenomenon were made in the 15th century in Augsburg, Germany, with the invention of rifling in a barrel. They must have seen an increase in accuracy right away because 500 years later, all rifles have rifled barrels. Observations can be seen in this brief video where a bullet is shot from a barrel at 224,000 frames per second. As you can see from the video, the bullet leaves the barrel with spin. This is what causes the increase in accuracy. The hypothesis for this main question is that modern-day technology with weapons has seen the implementation of rifling in barrels of almost all kinds. The simple concept behind this is that rifling in barrels leads to the bullet leaving with spin. This spin results in a more accurate shot than one seen in smoothbore barrels. Rifling of a bullet causes a decrease in drag, thus having a direct effect on the flight pattern. As you can see in the picture in the bottom right corner, the bullet cuts through the air with the external flow lines showing smooth air travel. The answer to the question of why does bullet accuracy increase relates directly to what we talked about in class relating to external flows. The two equations we analyzed were the ballistic coefficient equation, which relates directly to the drag coefficient equation. These principles led to our analysis. The rifling in a gun barrel causes the bullet to spin. This spin gives the bullet a gyroscopic stability factor, which can be directly analyzed with the ballistic coefficient of the bullet. As the stability factor of the bullet is increased, the ballistic coefficient also increases to some extent. This increase in the ballistic coefficient directly causes a decrease in the drag coefficient, which can be seen in the two equations above. By reducing the drag coefficient, the external flow around the bullet will become more laminar. A laminar flow relates directly to a smoother flight path. With a high drag coefficient, the external flow on the bullet would be turbulent, causing a decrease in accuracy. Therefore, the spin from the rifling in a barrel has a direct relationship on the decrease of drag. A decrease in drag leads to a more consistent flight path, meaning greater accuracy. And as you can see in our graph, with a low drag coefficient, it falls in the laminar flow region of the graph. And this is exactly what we want to improve accuracy. The final conclusions that we made from this analysis were by putting rifling in a barrel, it creates a gyroscopic stability factor for the bullet leaving the barrel. This stability factor is directly related to a decrease in drag to a certain extent. And this decrease in drag causes an external laminar flow, which causes a more consistent flight path. And this more consistent flight path leads to a greater accuracy. With too little spin, it would cause the bullet to tumble due to the turbulent external flow. And with too much spin, the bullet would potentially be destroyed under the large amount of force, or would just lead to a decrease in accuracy because of the overstabilization. Because of this rifling in a barrel, the final answer to the question is that yes, rifling in a barrel does increase accuracy when compared to a smoothbore barrel. Thank you.